Greetings and good morning to Sir Hardy. Uh, Today we are going to talk about differentiation. So before that, let me introduce my group members. First is Teh Ting Hau, 07 DEE 20F 2046. Second, Zeno Brayen Bonny, 07 DEE 20F 2042. Maximillan Tony, 07 DEE 20F 2026. Lastly, me, Micheal Foo, 07 DEE 20F 2036. So let's start.
Introduction for differentiation. In calculus, differentiation is one of the two important concepts apart from integration. Differentiation is a method of finding the derivative of a function. Differentiation is a process in maths where we find the instantaneous rate of change in function based on one of its variables. The most common example is the rate change of displacement with respect to time, called velocity. The opposite of finding a derivative is anti-differentiation.
For daily life use of differentiation, differentiation and integration can help for solve many types of real world problems. We use the derivative to determine the maximum and minimum values of particular function, for example, cost, strength, amount. How differentiation can be applied in real life setting. To calculate the profit and loss in business using graph. To check the temperature variation. To determine the speed or distance covered, such as miles per hour, kilometer per hour. Derivative are used to derive many equations in physical material used in a building, profit and loss, etc. What is rate of change? Rate of change is used to mathematically describe the percentage change in value over a defined period of time, and it represents the momentum of a variable. How is rate of change used in everyday life? Other example of rate of change include a population of rats increasing by 30 rats per week. A car traveling 68 miles per hour, distance travel changed by 68 miles each hour as time passes. A car driving 27 miles per gallon, distance traveled changed by 27 miles per each gallon.
For the formula, this is for the formula dy dx. The formula of gradient is dy dx, and if the second dy dx is smaller than 0, it will be maximum point. If the second dy dx is higher than 0, it will be minimum point. If the second dy dx is equal to 0, it will be inflection point. Next. The calculation, the dy dx for the y is 3x squared plus 6x minus 9. If the gradient is equal to 0, it will be double x. Number 1 is 1, second is negative 3. when x is 1 equal to 1, the y will be equal to 1. And when the x is equal to -3, the y is equal to 33. So the stationary point is 1, 1, and another is -3, 33. Then to find the maximum point or the minimum point, we should do the second dy dx, and when the x is equal to 1, the second dy dx is minimum point, and when the x is equal to -3, it will be maximum point. Next, for the graph, it will be have maximum point and minimum point. Okay, that's all.
So in conclusion, after performing this work, we understand the idea of differentiation from first principles and how to differentiate power functions. We also know the way to find stationary points of some functions, also to determine the nature of some stationary points using either the first or second derivative tests. Plus, we also able to understand and work with derivatives as rates of changes in mathematical models. Thank you. That's all from us.